where it is necessary to obtain samples beyond a depth of 2 meters. Drilling is carried out by machines. The samples are collected as drilling progresses, and depths at which samples are collected are noted. These activities will also help determine any difficulties which may arise during the construction process. For example, the depth of the water table, if timbering will be needed. Soils are classified into 2 broad categories: coarse-grained soil and fine-grained soil. Coarse-grained soils include gravel and sand, which consists of relatively large particles that are visible to the human eye, whereas fine-grained soils, such as silt and clay, consist of much smaller particles. Coarse-grained soils have higher bearing capacities and are more stable as a foundation material than silt or clay. Clay soils, in particular, tend to be unstable because they shrink and swell considerably with changes in moisture content. Unstable soils may cause a site to be unbuildable unless a very expensive foundation is put in place. Most soils are a mixture of the various soil types. There is a simple test one can do to determine if the soil is sand or clay. 1. Dig a hole in the ground 1 meter deep and take out a sample of soil. 2. Place a portion of the soil sample in a transparent bottle until it is 1/3 full. Add another third of water and 1 spoonful of salt. 3. Shake the bottle strongly until the mix is uniform. 4. Let the mixture rest for 24 hours. 5. Sand will settle on the bottom, clay above the sand, and silt, the finest grained soil, will settle on the top. Measure the heights of the various soils. 6. If more than half is sand, the soil is sandy, and if more than half is clay, the soil is clay. These videos are intended to be used to complement the instruction of this subject, by classroom teachers as a teaching aid, by independent learners as a review tool, to enhance and improve the understanding of these topics, resulting in improved performance in CSEC examinations. Segment 2. A foundation is the base on which a building rests, and its purpose is to safely transfer the load of a building to a suitable subsoil. Building regulation requires that the foundation of a building shall 1. Safely sustain and transmit to the ground the combined dead and imposed load so as not to cause any settlement or other movement in any part of the building or any adjoining building or work. 2. It should be deep enough to safeguard the building against damage by swelling, shrinkage, or freezing of the subsoil. 3. It should be capable of adequately resisting attack by sulfate or other corrosive matter present in the subsoil. There are many types of foundation that can be considered under 2 headings. 1. Shallow foundation. Shallow foundation, those which transfer the loads to subsoil at a point near to the ground floor of the building, such as strips and raft. 2. Deep foundation, those which transfer the loads to a subsoil some distance below the ground floor of the building, such as a pile. The 4 major types of foundation are 1. Raft foundation. 2. Pad foundation. 3. Strip foundation. And 4. Pile and beam foundation. Raft foundation is one which covers the entire area of the building and may extend beyond it. It consists of concrete that is suitable, reinforced, and up to 300 millimeter thick. Pad foundation is generally isolated foundation consisting of a block of reinforced concrete, meant to support reinforced concrete or steel columns, especially in framed buildings. 3. Strip foundation is the commonest type of foundation and is used on most domestic and small commercial buildings. A strip foundation is basically a strip of concrete running under the load-bearing wall of the building. The depth and width of the foundation depends on the load of the building and the nature of the soil. So how does soil-bearing capacity relate to the size of the foundation? The lower the bearing capacity of the soil, the wider the foundation needs to be. If the soil is very strong, the foundation isn't even strictly necessary. Just the soil under the wall would be enough to hold the building up. For typical soil, a 400 millimeter or 600 millimeter wide footing can more than handle the relatively light weight of an ordinary structure. If you build on soft clay soil, or if there's a soft zone under part of your foundation, you might need a much wider foundation. Pile and beam foundation is an alternative to deep strip foundation. It is required when buildings are erected on clay, marshy, or soft soil. The piles enable the builder to have the weight of the building carried by firmer ground below the poor topsoil. The consequence of foundation failure is what is called settlement, where the building sinks in the ground. It is even more catastrophic if different parts of the building sinks unevenly, which can cause severe cracking in the structure. This is called differential settlement. These videos are intended to be used to complement the instruction of this subject, by classroom teachers as a teaching aid, by independent learners as a review tool to enhance and improve the understanding of these topics, resulting in improved performance in CSEC examinations. Segment 3. Building Drawings. The first step towards the construction of a dwelling is to prepare a drawing or a sketch. Drawing is important as they contain information regarding the size, shape, type of materials, and important specifications for the safety of the buildings. An architect will use the preliminary information obtained from the site investigation and develop a set of working drawings. Some builders and draftsmen also provide this service. These drawings will contain information regarding the size, shape, type of materials, and important specifications for the safety of the building. Working drawings show the detailed plans, sections, and elevations of a building. They are drawn to a suitable scale and indicate the location and shape of the building and its structure. The working drawings are the basic documents that are used by the main contractor and subcontractors on site to construct the building. They may also be used for other purposes such as 1. Obtaining planning and building control approval from the local authority. 2. Preparation of work specification. 3. Preparation of bill of quantities. And 4. Preparation of tender estimate for the project. The drawings should include 1. Site plan. The site plan shows the location of a building on the land it will be built on. It is an overhead view of the construction site. A site plan shows the setback from the boundary lines and various features of the land. The floor plan. The floor plan is an overhead view of a building with the roof removed. Dimensions are drawn between the walls to show room size and wall length and thickness. The floor plan is arguably the most important drawing. Foundation plan. Foundation plan is similar to the floor plan, but it goes deeper in the ground, and it shows how the foundation is arranged in the substructure. Electrical plan is basically a floor plan that shows the locations of light fixtures, fans, outlets, light switches, and so on. There is usually a legend on the page which explains what each symbol represents. Frequently, the plumbing fixtures layout is combined with the electrical to form one drawing. Roof plan. Roof plan is used to show the shape of the roof and materials such as the roofing material, vents, and their location. Roof framing plans are usually required for complicated residential roof shapes and for most commercial projects. A roof framing plan shows the size and direction of the construction members that are required to frame the roof. Elevation is a set of plans that include 4 elevation drawings, one for each of the front, rear, and 2 sides of the building. The elevation view is a completely flat view. The elevation details the building height, the exterior materials used, including finishing and roofing. It helps give the prospective owner an idea of what the home will look like. The elevations specify ridge heights, the positioning of the final fall of the land, exterior finishes, roof pitches, fence locations, and other details. Floor plan views of the structure don't always provide enough information on how the building is to be constructed. Therefore, cross-sections will explain certain special conditions more appropriately. A cross-section is basically a view of the home if it were sliced vertically through the building. This allows one to view the home from the side and understand better the relativity of varying floor heights, roof framing, and other structural elements. Details. These are drawings that show a small part of the construction at a larger scale, to show how the component parts fit together. Section drawings at large scale are a standard way of showing building construction details. A full set of construction details need to show plan details as well as vertical section details. These videos are intended to be used to complement the instruction of this subject by classroom teachers as a teaching aid, by independent learners as a review tool to enhance and improve the understanding of these topics, resulting in improved performance in CSEC examinations. Segment 4. Preparing and stripping the site. One of the first undertakings in preparing a site for construction is clearing the site. Site clearance is defined as clearing, grubbing, removal and disposal of the vegetation, grass, debris, bushes, scrub, dense bushes, trees, hedges, undergrowth, stumps, roots, shrub plants, and the backfilling of holes due to the removal of stumps and roots. This may involve the demolition of existing buildings, the grubbing out of bushes and trees, and the removal of soil to reduce levels. Demolition is a skilled occupation and should only be tackled by a skilled demolition contractor. The removal of trees can be carried out by manual or mechanical means. The removal of large trees should be left to the expert. After clearing, the site is then stripped to remove the top layer of soil. This is in effect to sterilize the ground, since the top 150 to 300 millimeter or so will contain plant life and decaying vegetation. This means that the topsoil is easily compressed and would be unsuitable for foundations. Topsoil is valuable as a top dressing for gardens and is stockpiled for landscaping at the end of the construction. The method chosen for carrying out the stripping of the site will be determined by overall economics. 150 millimeter stripping depth is common, but depth varies depending on site. Most building sites are not level, and consequently, before any building work can be started, the area covered by the building must be level. This operation is called reducing level. One of three methods is usually chosen. These are: 1. Cut. This method has the advantage of giving undisturbed soil over the whole of the site, but has the disadvantage of the cost of removing the spoils from site. 2. Fill. A method not to be recommended because if the building is sited on the filled area, either a deep foundation would be needed or risk of settlement at a later stage would have to be accepted. 3. Cut and fill. The most economical methods because if properly carried out, the amount of cut will equal the amount of fill. Depending on the volume and nature of ground to be excavated or filled, the work can either be done by hand or by machine. When done by hand, earthworks are usually done by a casual, unskilled laborer with the guidance of a skilled person. The most common tools in manual earthworks include pickaxes, spades, and shovels. Movement of earth is usually by the use of barrows. When the work is to be done by machine, the plant involved ranges from compressors, scraper, bulldozers, and the like. Movement of material is usually by use of tipper trucks. In the case of hard rock ground, blasting is usually undertaken. Clearing termites. The building site and surrounding areas should be inspected for termites as part of the process of clearing the site. Termites present a danger because they eat the cellulose in the timber in buildings where they cannot be seen. Destruction is often well advanced before it is obvious on the surface. To remove this danger, the termite nests must be dug out and its contents destroyed. The ground around a termite nest is usually treated with toxic chemicals. For this reason, you must take great care when handling the chemicals. It is advisable to wear gloves and goggles to prevent the inhalation of fumes. The chemicals and powders should be mixed in the open air. Check your understanding. The site and construction operations must meet the environmental standards. One of the essentials for a construction project is the land that becomes the building site. Work should begin after official permission has been given by the local authority. Zoning may include regulation of the kinds of activities which will be acceptable on particular lots, such as open space, residential, agricultural, commercial, or industrial. The working drawings and specifications should contain all the information that the contractor needs to complete the building. The site should be prepared before the work starts. Termite nests on site must be destroyed. The soil conditions should be checked before excavation begins. A soil test must be done to determine the nature and load-bearing capacity of the soil. Revision exercises and questions. 1. Why is it important to establish land ownership? 2. What are the environmental protocols that should be observed during the construction project? 3. What is meant by the term zoning? 4. What is the purpose of the working drawings? 5. Why should termite nests be destroyed on a building site? 6. Why should the contractor dig trial holes before work begins? 7. Why do we need to test soil when constructing a building? 8. List equipment used for stripping a building site. 9. List tools or equipment used to set out a building. These videos are intended to be used to complement the instruction of this subject, by classroom teachers as a teaching aid, by independent learners as a review tool, to enhance and improve the understanding of these topics, resulting in improved performance in CSEC examinations.